What's going on, guys? Tonight I'm here to explain the LabVIEW program behind my memory game. This is my front panel right here. These are the lights that will blink, and here's where I can input and change a few things. This is where the high score pops up, current score. This is where you set the maximum value of integers that you can put into the array. So this will be the number of times the LED blinks, and this is a value for waiting to allow for the user to input the button once and not multiple times. So in between each button press it will wait approximately a quarter of a second until it reads again. I'm going to explain to you my block diagram now. It starts over here. Right here is where we generate an array and put that into this sequence. In here I'm going to generate a random number 1 through 4, insert that into this array at the index according to the loop iteration right here. That array then passes to the next sequence where we insert an off state in between each random number that has been generated. The random number array is this section right here, and this is where we insert the off state. So at by this loop iteration, every other one we're going to input an off state, and by default an off state is 5 for my setup. Otherwise we pass through the current number in there. The original array is passed through this sequence and through this sequence onto the next. The off-state array, which has the pauses in it, is then sent to the LEDs. That is right here. This right here will blink according to the loop iteration which LED is assigned. And so whichever one it is, it will turn true and then light green, blue, red, or yellow. These wait timers allow for the blink to stay on for a half of a second in between transitions, and so that way it'll give the user enough time to see the lights. This sequence right here is what reads the inputs from the user. This is the input wait variable I showed you earlier on the front panel right here. That right there controls the latter half of this, where we wait after the users press the button. Right here is where the DAC assistant gets the input from the button. I'm reading one analog input across the 4 buttons that I have set up in a voltage divider. I multiply that to get a whole number out, so that way I can have these case statements by the whole number. And as I've associated each one of these with a value and with which color it represents. Whenever I'm not reading any input, I put out a 5, which allows me to keep reading, is pretty much what this does. So if I get a number that is less than 5 or less than 4, it will stop this. And so all of my buttons put out a value that is less than 4. After they press the button, it will then enter this wait, which will allow the machine to not read multiple times. It's somewhat of a debounce feature. Then all those values are put into an array, and that array passes through here. This is the original array. If you follow it back, you'll see it coming all the way through. And the original array without the pauses is then compared to the array that the user inputted. These two values are compared here, and if it's incorrect, we light up this. We also send that Boolean true down to here. This, when compared with the high score, will allow the high score to be entered into here. So I'll explain the high score feature now. Right here is where the loop iteration comes in. This loop iteration, -1, because that will be the number you have correct, is put into index 0 of this array. It is then fed through to here and then compared with index 1 of this array. I haven't explained where index 1 comes from, but I will in just a second. And if you have a number greater in index 0 than you do in index 1, I will then write to index 2. I'm going to write index 0 to index 2, and that happens right here. I'm then going to display your high score and send index 2 and the array back around to the next loop. So next time you play the game, whatever's in index 2 was the last high score, and then it is sent to index 1, the current high score. This is the value that will be compared against index 0. This is just a little bit of array flipping to store the high score. This sequence, or this case structure right here, is actually what displays the high score. I have a physical display to the high score, and I have 2 digits of a 7-segment display. 1 digit I'm actually driving with a 7447, and that occurs here. I actually drive 4 lines to a 7447 BCD decoder. The other 7-segment display, I did not have enough outputs to drive, so I chose to just drive it low when I wanted it on and drive it high when I wanted it off. And I'm actually just driving the 1 digit. So the only numbers I can represent are up to 19. I cannot represent 20 with this sequence. Oh, I should show you the beginning. Whenever I initialize the program, I initialize this digit to be on. Well, off, actually. If you put 5 volts to it, it cuts the digit off. And then whenever the user gets a score above 10, right here, whenever we're, well, 9 or above, whenever we're at 10, it will then cut this digit on. So then you'll see the 1 digit cut on, or the tens digit cut on, representing a 1. And then I'll minus the value, I'll minus 10 from the value, and then I'll display that on the ones digit, according to whatever that value is. I then send this array back through via a shift register to the other end. That way that the sequence can continue to add upon itself. So if it is red, then it will be red yellow, and then it will be red yellow green, and just continue so on, building upon itself. But this is my program. If you have any questions, please leave them in the comments. Thank you for watching.